punch it, engage. Chevron 7, locked. Never heard of the Millennium Falcon? That's the ship that made the castle run in less than 12 parsec. Welcome to Science Sci-Fi, connecting the public to science and technology through storytelling. My name is Rodas Friedman. I'm a science fiction writer and an IT professional. And today we are not going to dive into exotic, faster than light wormhole things that are not currently only hypothetical, but we are only going to discuss how interstellar travel is possible with what we know today, with the physics we know today, with the technology that we may have maybe 100 years, 200 years in the future, with nothing hypothetical. But before we dive into the presentation, I just want to say that I'm a big Star Trek fan, yay! And I met a few Star Trek actors in the last Comic Expo that I've been to last week. But now, let's dive into interstellar travel. So, what is possible in the foreseeable future? I'm going to divide this presentation into three parts. First part, what kind of propulsion system do we need in order to get at some point into another star system? And the example I'm going to use is Alpha Centauri, that the closest star system, 4.2 light years away from Earth. Second topic is what kind of hazards we're going to meet on the way, and how can the crew and the settler on the spaceship, on the Starship, can survive the voyage. And of course, I'm going to intervene science fiction picture throughout the presentation. Here is from a TV series called The Ark. So, what do we have? First of all, we have chemical rockets. That's the type of rockets we have today. Now, if we use like the Starship, like a spaceship like the Voyager or the Pioneer that are currently in interstellar space that were launched in the 1970s or the 1980s, those are going to take something like 70,000 years to reach Alpha Centauri. Now, if we do really optimize chemical rockets and we do gravity assist with the sun it can get something up to 100 times faster than that, but still, the voyage to Alpha Centauri on a chemical rocket will take 7,000 years. That's a very long duration that will take many generations. And of course, during the voyage, you will need nuclear energy in order to sustain the life and the ship for so long. And if you already use nuclear energy, then why not use nuclear propulsion? So, and also I made a video about nuclear propulsion. I'm going to put it in the description. Check it out. Nuclear propulsion. What we have, first of all, fission nuclear. That's how things that are splitting the atom. Nuclear thermal is not much better than chemical rockets, maybe 3 or 4 or 5 times better, but there's limits to it. But we have nuclear fission electric. That means either ion drive or plasma drive that is throwing out electrified particle at a very high speed, and it uses nuclear energy in order to accelerate those particles. These theoretically can reach something like 1% the speed of light. That means that the voyage to Alpha Centauri may take 500 years or 1,000 years. That's already much better than 70,000 years. We have nuclear impulse. That's a concept from the 1960s, like the Orion project. That's what you see here on the picture. It's basically throwing up nuclear bomb and blowing up in space. And when they're blowing the bomb, it pushes the spacecraft into the other direction. Those can theoretically reach even 5% the speed of light. This will give us a voyage time of something like 100 years. And this engine, this kind of technology was already in the work in the 1960s. For various reasons, we stopped developing it. Basically, it means blowing up nuclear weapon in space and in Earth in order to launch it. And there are a lot of reasons why not to do that. But the option is still on the tables. And then we have the most advanced nuclear rocket that is not yet commercial, but it may be very, very soon. That's fusion reaction. And fusion rockets are way more effective than fission reactions. That can reach theoretically a speed of 10% the speed of light. That means that we can take a voyage to Alpha Centauri with a crew that will take something like 42 years. Are these the limits of what we can perceive right now? No, we can even do better. Light sails, this is another theoretical concept that has been explored in science fiction. And also there is one, the Planetary Society launched one test with a light sail or solar sail. The idea here is that you have a very, very large sail, and then you either use particle from the sun, like solar wind, in order to accelerate the ship, or you can even use laser that you put a laser in on Earth and on Mars and in one of the moons of Jupiter, etc., etc. And those are very, very powerful lasers, and they will concentrate light on the Starship, on the sail, and that will accelerate the Starship even further. The advantage of that is the fuel for all these laser systems is not on the ship, so you don't need to carry all the fuel around. It's staying behind. There will be some problem with deceleration. To decelerate, you can only use the light from the approaching star. So deceleration is more complex, but you can combine light sail with nuclear fusion and maybe cut down the voyage by 20 years. But that's not all. We'll still have something even better in our sleeve, but I'm a bit more skeptical about that, for maybe it will take more longer than 200 years. And that's antimatter propulsion. Unlike nuclear fission, when you split an atom, or fusion, when you combine an atom, that maybe 0.1% of the atom's mass is turned into energy, antimatter, when you take antimatter and combine it with matter and you merge them together, 100% of the mass is turned into an energy. This is the most efficient fuel we can theorize right now, but this is very, very difficult to make and to maintain. Currently, we can only make it in huge particle accelerator, and we use a very, very tiny fraction of the gram. It's going to cost trillions of dollars to have enough fuels, and we don't know how to contain it at the moment, because the moment we created antimatter, it immediately merged with a regular matter, and turned into energy. So skeptical, but let's go through it. This is the most complex to produce, most advanced, most fuel efficient. With it, we can reach 40% of the speed of light, and in some theoretical scenario, maybe even 90% the speed of light. I think here in Avatar, the spacecraft that came from Earth used it, but they had some kind of material called adoptanium that we don't have at the moment. But once we get into a relativistic speed that we are a large percent of the speed of light, like 90%, 99%, then the time for the crew is slowing down. So that means that if we go at 90% the speed of light to Alpha Centauri, it should take 5-point-something years, less than 6 years for Earth. But for the crew on board the Starship, it will only take 2 years and 8 months at 90% the speed of light. If you can go faster, the time that the crew will spend on the ship will even shrink over the day. So what do you think is the most optimistic scenario? I would say fusion propulsion, because we are not very far from fusion reactors. So we may be able to build something within decades, definitely within centuries. And with fusion propulsion, we can reach 10% the speed of light. So this is something that is maybe doable in a not too far future, in order to have some kind of a huge spacecraft. It's not too exotic. Maybe we could build something like a Dyson sphere. I'll put a link in the description about the Dyson sphere. This is a big cylinder that's rotating and have artificial gravity, and we can have a really, really close loop. Maybe we can have a crew survive for 40 or 50 years inside that spacecraft. We will talk about that later. One example is the Behemoth from the Expanse TV series. It's a generational ship, and we may be able to do it in the not too far future. Next topic, hazards. Interstellar voyage could be very dangerous. Even at 10% the speed of light, even if you use a small asteroid, even a small dust speck, if it at that speed, it will have a huge amount of energy and it cause a lot of damage. So one of the solutions that is I saw proposed in some science fiction book is to clad a spaceship with ice. So all these tiny particles that aren't too many of them in interstellar space, but they still exist. So even if you go at a very, very high speed and it hit the ice, it chops some of the ice, but it will save the speed in most time. So this could be some kind of solution. Of course, it will make the ship heavier. That means it will be slower or it will need more fuel, etc., etc., etc. Complex, but not impossible. Other issue is galactic cosmic radiation. How do we solve that? If it's a voyage that takes decades or centuries, the crew will absorb a lot of galactic cosmic radiation. There are ways to address this. One is have some kind of protection and magnetic field or very thick walls. Another one is advance in medical science to be able to repair radiation damage to the body. There are a different approach for that. They are not. We should be able to do it in the not too far future, definitely within 100 years. How to keep the crew alive. Some concept on how generation or a spacecraft can go from Earth to another star system. Again, we're going to focus on Alpha Centauri, which is the closest star system. One option is generation ship, suspended animation, frozen embryos, and fast travel. Generation ship, again, it's like a big cylinder, and it could be like O'Neill cylinder that have nuclear fusion propulsion, and they travel very high, some percentage of the speed of light. And we have to be able to have 100% closed loop biosphere, 100% recyclable. That means it cannot leak any significant amount of air or material, and everything we have in the biosphere is going to be recycled and reused. And the only thing we need unlimited or nearly unlimited supply is energy. So we are not there yet in the space in the International Space Station that we have in Earth orbit, where it's not closed loop, it's not 100% recycled, but we are getting better and better in time. So maybe once we have a colony on Mars and in the asteroid belt, we get even better than that. And maybe when we have O'Neill cylinder, we can get even better. And at some point, hopefully within 100 years, we'll have system that is 100% closed and it could survive for decades or centuries without external supply, providing that we have the energy. Some example from science fiction, and again, is the Behemoth from The Expanse, TV series and book series, Rendezvous with Rama, a very famous book by Arthur C. Clarke, Wall-E, they have this big cruise ship in space, etc. Suspended animation, this is something that I've seen in many science fiction movies and TV series. To name a few is Passengers, with and another one is Avatar. Even though Avatar, it was only 5 or 6 years voyage, they still prefer to keep the people in suspended animation. Another one is The Ark, TV series that is being shown right now. The basic idea is that the crew go to sleep and wake up a few years or a few decades later once the ship arrives to its destination. That way, you don't need a closed loop, you don't need to recycle everything, and you need to consume food. So you have more limited supplies and more limited recycling. But we need the suspended animation or cryo sleep technology that is currently not entirely available, but it's not far away future. This is something that may be resolved within a few decades. And another approach is frozen embryos, similar to suspended animation, just you don't freeze the whole body, you just freeze embryos. So the ship is maintained and run by AI and robot, and most of the crew is most of the crew, future crew, is embryos. Of course, once you get to the destination and either settle a planet or new cylinder, build them from asteroids in the new solar system, then the robots will need to grow up the humans, embryos, into kids in some kind of artificial womb, and then educate them, teach them how to survive. We saw it in Raised by Wolf. Also, it will concept was discussed as Plan B in the movie Interstellar. It's another way to colonize another star systems without taking too much resources to be able to sustain the population in a starship for many decades and generations. And the last way is travel very, very fast. Like if we can go into relativistic speed, 90% the speed of light, for the crew, the voyage will take less than 3 years. This is something that is doable with near future technology. Like with the International Space Station, we can stay 400, maybe even more in space. 3 years, it's maybe 1,000 days. We can build something that who can survive for that long. So thank you very much. I hope I was able to convince you that interstellar travel, even with engineering system that we can perceive today without any exotic or hypothetical theories, is still doable, is still possible within, say, 100 or 200 years in the future. I hope you enjoyed the show, and don't forget to subscribe and hit the like button, and see you on the next video. Bye for now.